Hello, Honors Algebra 2. Welcome to a continuation of Chapter 5. I'm going to start with saying I wish you guys luck. I don't know. I don't know exactly when your tests are. You could have had them already. But in terms of AP tests, I hope you guys, I wish you guys luck. You guys are all very smart, capable, lovely human beings, and you guys can all be very successful on these tests. So take your time. I know that's hard to do in this time frame, but take your time, check your work, do your best. Just remember, you got this. So good luck. My Google's talking to me. Apparently, my words were so encouraging that she wanted me to hold on tight to those. So, okay, we are going to be talking today about some of our rules of logarithms. They're really similar to exponent rules, right? We have exponent rules, and logarithms are just a different way of writing an exponent. So, they have a lot to do with it. So what I'm going to do is I'm actually just going to get into the first rule. Our first rule is something we've already done. It's basically saying, let's get colors because, how I feel. So changing an exponential. So we have an exponential to logarithmic. And really, this arrow doesn't go just one way. It can go this way as well. So the base in an exponential is the same as the base in a logarithm. The exponent in an exponential is what the logarithm is equal to. And the exponential is equal to the argument of the logarithm. So what I want you guys to do, we've already done examples like these. What I want you guys to do is pause me here. Well, don't pause me. Listen to what I'm going to say. So I want you guys to do example 1 and example 2 on your own, and then come back and check your work. Make sure that you agree. So now pause me here, do 1 and 2, and then come back to check your work. Okay, so you should be coming back to check your work. So changing an exponential, so a logarithm to an exponential, remember it's m to the p power equals n. And remember, I showed you guys a little bit of the loop-de-loop. If doing the loop-de-loop helps, great. So remember, I'm going to try and do it without you guys seeing my hand covering it. It would be m to the p power equals n. And so hopefully I didn't cover that. Sorry if I did. It's hard. Okay, so hopefully then you've also written this in logarithmic form. Now the loop-de-loop works the same exact way. It would be log base 5 of 125 equals 3. So see how the pattern of the loop-de-loop works exactly the same. So again, that's log base 5 of 125 equals 3. And when you guys are typing these into your homework for your answers, when you're typing logs and you need to write a base, use there's a button next to the exponent because that's a superscript. There's a button for a subscript next to it, and that will allow you to do a base. Okay. So log base a of 1, so it's basically saying whenever there's an argument of 1. Now, I'm going to have you guys think about this one, and I'm going to write it as an exponential. And so I'm going to put log base a of 1, and I'm going to put x. So a to the x power equals 1. All I did is I just rewrote it as an exponential. Well, what exponent is going to turn something, any number, no matter what the number, what exponent is going to turn something into 1? So think about that. What's our exponent here? And if you're thinking 0, you would be correct. So this is anytime the argument is equal to 1, no matter what the base is, it's going to be equal to 0. So really what's key here is that the argument is equal to 1. Okay, so look at your 2 examples, log base 16 of 1. And then also with this one, there is no base. So when there is no base, what can you assume that the base is? And if you're thinking 10, you'd be correct. So remember, this is the same as log base 10 of 1. We just don't ever write the base of 10. We can assume. It's just like we never write the index number for 2 when we have a square root. We just can assume. So I want you to think about what's the answer to example 1? What's the answer to example 2? Come back, check your work. Okay, these should have been very easy. They have an argument of 1, so it's equal to 0. It has an argument of 1, it's equal to 0. Now, I do want to show you this one, because remember, that button is on your calculator. Log base 10 is this log button. So, like on your calculator, you have a log with base 10 and a log with base E. I use this one primarily the most, and I'll show you we'll use that in the next video. I'll start talking more about it. Actually, probably this one. Okay, so if I did log 1, it would get me 0. So you can use, I'm going to be showing you guys how to use your calculator and how it's going to help you. Okay, so our next property is when the argument and the base are the same. So I'm just going to write, again, log base A, I'm going to set it equal to x. So a to the x power equals a. So what exponent is going to make it so the base is equal to the answer? So think about that. A to the what power equals a. Now, what if I wrote it in terms of numbers? 5 to the what power gets me 5. And if you're thinking 1, you're correct. So whenever the base and the argument are the same, your log will simplify to be 1. So the base and the argument have to be the same. Okay, so again, I want you guys to look at example 1, example 2, and tell me what those simplify to. Okay, again, no base. We can always assume that that has a base of 10. So remember, that's going to be log base 10 of 10. Argument, base are the same, so it's going to simplify to be 1. And then ln e. Remember, ln is log base e. Argument, base are the same. It's going to simplify to be 1. Now, this one is huge, actually, and this one plays and I'll show you. So, not why it's so important, but ln 1. Oh, I'm sorry, ln e. She's crazy. Okay. ln e gets us 1. Log 10 gets us 1. Now, ln e is one of those ones that I would basically memorize. ln e is so big. We use it so much to simplify. So whenever you see ln e, if you know that you can cancel it out and simplify it to be 1, that's huge. That one is probably, like I said, this comes into play so much throughout this unit. It's huge. So if you have that memorized, that one's super important. Okay, so, and honestly, you really don't have to have these memorized. You can think about them exactly how I thought about them here. So, it's up to you. However, I would have the ones that I bolded. I would have those memorized, and obviously I would definitely have that one memorized. Okay, so the power rule. Now, when we have exponents, a power rule, when it's a power to a power, what do we do with those exponents? Well, if you're thinking we multiply, you'd be right. And so what the power rule says for logarithms, if I have a power on the argument, I can actually move the power to the front. So I'm going to move the r to the front and multiply instead. So it's going to be, instead of that power on top, it's now going to be r times log base a of m. So if I were to look at my first example, log base 5 of x squared, and it says simplify, the only thing I can do, and the only thing it means when it says simplify, is to apply the power rule. So take the 2, we're going to move it to the front, and this one is so common. We deal with this one all the time. So it's going to be 2 log base 5 of x. You can put the multiplying. I don't. Most people do not, because we assume when something's right next to it, it's multiplying. And that is it. So what I want you guys to do, look at example 2 and think about how would you simplify that one further. So pause me here, try example 2 on your own, and then come back, check your work. So it was the same thing. Even though that square was on the outside of that big parentheses, we still just move it to the front and leave the x plus 3 as the argument. And that's it. Okay, so with this one, log base a of a to the r power. So, what I want you guys to think about, I want you to use your properties from up above, and I want you to think about what is this going to simplify to. So use the 2 above that we've already applied and think, what is this going to simplify? If you need to pause and think about it for a minute, pause and think about it for a minute. Okay, so if you hopefully thought about it, I'd first apply the power rule. So this would become r log base a of a. And what do we know happens when the base and the argument are the same? What does it cancel out to be? Well, it cancels out to be 1. And so r times 1 is just r. So this rule is r. So what I want you guys to do is think about example 1, example 2. What are those going to equal? Okay, so you should have come back. You should have thought about those. If not, pause me, think about them. And then, okay, so ln e to the negative 10. The negative 10 would come to the front. We don't even have to think really about that. But the negative 10 would come to the front. We know ln of e is equal to 1. So this is going to simplify to just be negative 10. Okay, and then base argument are the same. We'd bring the power to the front, 81. This would simplify to be 1, so it's just 81. Okay, so let's get into our product rule. Now, like I said, I would definitely have memorized the power rule. Actually, I would definitely have memorized this, the power rule, the product rule, the quotient rule, and the change of base rule. Okay, so what the product rule says is, think about when we're multiplying with the same base, what do we do with the exponents? Well, we add them. And so the product rule with logs is, this is equal to, so m and n are multiplying right next to each other. They're multiplying. So this is equal to log base a of m plus log base a of n. So same base, the arguments, now we just split them up using addition. So the product rule, we split them up using addition. So we can go back and forth. You can go from like the expanded form to the condensed form, or the condensed to the expanded. Now, why do we use this and why is this important? So we don't know 8 to the what power gets me 4. And we don't know, again, 8 to the what power, we don't know what gets me 16. But if I were to actually condense this, so they have the same base, which is key. If they don't have the same base, we cannot apply this rule, and they're adding. So we can actually combine the arguments by multiplying them. So that would be log base 8 of 4 times 16. Well, log base 8 of 4 times 16, 4 times 16 is 64. You don't need the parentheses around that one. I don't know why I did it. And now to evaluate that, we just think 8 to the what power gets me 64. Because remember, you can just always think about it as an exponential. This would be 8 to the what power equals 64. You can always rewrite it. Sometimes, like I just think about it, 8 to the what power equals 64. And that's 2. 8 to the second power gets me 64. So log base 8 of 64 is going to simplify to be 2. So before, we couldn't evaluate this. But then when we use the product rule, we actually can evaluate it, so it turns into a number. Okay, now sometimes in your, on your homework, on your test, whatever it is, you will just be asked to expand it even when there's variables. So expanding it means like taking it from the multiplying it and bringing it to the plus. So, okay, there's a few things that we would do here. So with this one, they're multiplying in between, so I can separate those two arguments with addition. So the base is going to stay the same. It's going to stay log base a of x squared plus log base a of y to the fourth. So we separated them. They're multiplying, so we separated the arguments by addition. Now we have one more thing that we can do. What's another rule that we can use to help us here? And if you're thinking power rule, you would be correct. So we can also apply the power rule, which we're going to, and we're going to talk more about kind of the order of all the rules and stuff in the next video. So this would be 2 log base a of x plus 4 log base a of y. And now that's fully expanded. There's nothing more we could do, and that would be my final answer. Okay, so the product rule is another super important one that you guys have to, you have to have it memorized definitely for pre-calc. Okay, so then, what I would say too is just knowing these and being familiar with them is going to be super important to make these problems easier. So the more you know them, the easier that these problems become. Okay, so let's look at the quotient rule. Think about when we're dividing exponents, what do we do with when we're dividing bases with the same exponents, what do we do with the exponents? And if you're thinking subtract, you would be correct. So the quotient rule is log base a of m minus log base a of n. So what's really important with the quotient rule to remember is anything that's on top is going to be a plus, and anything that's on bottom is going to be a negative. So it's going to be a plus, always whatever's on top, and a minus, whatever's on bottom. So let's kind of look at that. So when we condense this one, I look to see, okay, this is a minus, and then this doesn't have a sign, but we can always assume the sign when there is no sign is a plus. So that means that this is going to go on the top, and this one is negative. It's going to go on the bottom. So when I condense it as 1, I'm going to rewrite that. Again, I have to double check. I know they do, but I double check. Do they have the same base? And they do. So to condense it, I would write it as log base 2, x plus 1 is going to go on top all over x minus 4. Now, what's really important is now this has become the argument. This is not log base 2 of x plus 1 divided by log base 2 of x minus 4. That log base 2 goes to that whole argument. So, be careful. Don't write them as two separate logs. They're not two separate logs when you're dividing. They're two separate logs when they're subtracting. It becomes one log when you divide them. Okay. So let's go into the expanding. So when it's on top, it's going to be a plus. When it's on bottom, that whole thing. Now, this isn't multiplying together, they're adding. So that's a whole thing. So that whole thing is going to go on the bottom. Just like this whole thing, x minus 4 went in the bottom, that whole thing, x plus 1, went on top. So when I separate that, that would become log base a of x to the 4th minus log base a of x plus 4. Whenever my argument is bigger than just one number, I always write parentheses around it. It just helps to distinguish, this is the whole argument, instead of maybe it's log base a of x, and then the plus 4 is on the outside. So I like to put, when there's more than one term, I always put that in parentheses. Now, is there anything else that I can do here to help simplify this? And if you're thinking power rule, you're thinking correct. So we want to move that 4 to the front. That's the only power we have. So this fully simplified, fully expanded would be 4 log base a of x minus log base a of x plus 4. Okay, so our last couple, this next one is just kind of up here, just understanding logs, and here understanding logs. So if I have a, and that's giving this entire thing, a log base a of m, that's an entire exponent, and I'm just going to set it equal to x. Now, if I rewrote that as a logarithm, so that would be log base a of x equals the exponent, so log base a of m. What do you think x is going to be equal to? Well, x arguments, you can set the arguments equal to each other when the bases are the same. X is going to be equal to m. So this whole thing, and the base of the exponent is the same as the base of the log. It's m. I'm sorry, when the base, of the exponential function is the same as the base of the log, it's going to simplify to be the argument. So take a second. I want you to look at example 1, example 2, and what do you think those are going to simplify to? So if you need to pause me here, think about those on your own, come back, check to make sure you did those correctly, and that's that. Okay, so the base and the base are the same, so it's just going to simplify to be the argument. It's going to simplify to be 19. This one, the base and the base, we know the base is the same here, right? Because the base of ln is e, and so it's going to simplify to be 12. We can double check that too. I can go into my calculator and double check. So e to the ln of 12, what is it going to simplify to be? 12. Okay, now change of base rule is huge. It's something that is really important, especially in a lot of these where we didn't have base 8 isn't one of the ones on every single calculator. ln, we have log base 10, we have ln, but we don't have every single base on every single calculator. So what the change of base rule says is we can actually change it to be any base. I can change it to be log base A, I can change it to be log base B, I can change it to be log base 10, whatever. But typically, like I said, we have ln, we have log base 10, so I change it to be that base. So I use ln most of the time. So this is going to change to ln of A over I'm sorry, I did that opposite. I was thinking poorly. I'm going to fix it. Okay, I'm sorry. I fixed it. It should be ln of m over ln of a. Now, okay, like I said, you can change it to be any base. I'm going to show you a few times. But the way that I, like how I caught myself that I was not doing it right is because of my embarrassing way to remember this. And my embarrassing way to remember this is you always have to remember to drop the base. And the base is a, and you got to drop it. So you got to drop the base to the bottom, and it goes to the denominator. So you can also use log base 10. So, that wouldn't have a base. So log of m over log of a. But really, this can be any base. So sometimes like log 10, ln don't work. It makes sense to use another base. So I'm just going to write it one more time. It can be log base b of m over log base b of a. So you can change this to be this rule works with any value as the new base. As long as you're consistent, as long as the base is the same on top and bottom. So like log base 5 of 7, not every single calculator has that button. And so if your calculator doesn't, which I'll show you on like the TI-80 whatever, those have this where you can do this. But I actually don't use it that often because it's more complicated to get to than just changing the base. So log base 5 of 7, I can do it again 2 ways. I typically, I always go to ln. The reason I go to ln is because it's 2 letters instead of 3. Yep, it's laziness. So again, we drop the base. 5 goes to the denominator. So it would be ln of 7 over ln of 5. So I can do that on my calculator to get the exact value. So ln of 7 and my parentheses, because if you don't, it's assuming that you're dividing within the argument. So ln of 7 divided by ln of 5, and that gets me 1.2091 rounded. Now, like I said, you can use any base. So I could do this with log base 10 and I would get the same thing. So if I did log 7 over log 5, will I get the same answer? Log 7 divided by log 5, and I do. Now, like I said, there is a button in your TI-84, your TI-83s. I don't know. I don't remember. I know like mine that I had, I think that's the TI-83, doesn't have this. But what you do is you go into math and you go all the way down and see that log base. So it will be log base 5 of 7. It gets you the same thing. However you want to do it. So log base 5 of 7 gets me, and we're going to always, with these, we're just going to round to 4 decimals. So 1.209, and that 6 rounds it to a 1. So I want you guys to try to find the exact value, however you guys want to do it, with log base 3 of 4. So you can change the base if you prefer to use that, the button like I showed you in here. Again, that's math. I mean, you guys can rewind this as many times as you want. A, and then you can type it in. Okay, but what I would do for this one is I would change the base. So it would be ln of 4. We drop the base, ln of 4 over ln of 3. I'm going to do that in my calculator. Ln of 4 divided by ln of 3. And I get 1.261. That 5 rounds up that 8 to be a 9. 1.2619. And if you use log base 10, Totally fine. You should have gotten to the same exact answer. Okay, so that is it. That's all we're going to do today. On the next video, we're going to get into a lot more examples, a lot more practice. So that's why you don't have any homework tonight. It's just introducing you guys to the rules. So if I were you, if you guys have time, I know this week is hectic. Last week is hectic. Next week is going to be hectic. But if you guys have time, make flashcards of these. Go on a Quizlet. I'm sure Quizlet already has like the log rules as flashcards. So I'm sure you could find those. But just, give these like a practice. Do it once or twice or 3 times, whatever, like right before you're going to bed. Just look them over. And because the more you know these, the better and more easier these problems will be. It's going to be harder if you don't memorize the rules. Even though I know you, like for right now, you don't have to have these memorized, but it just makes the process easier. The more you understand something, the easier a more complicated problem is going to be. So that's it for me today. I hope you guys have a great day. I thought I should give you guys an update though on my television watching, because I have watched a few new shows. I haven't actually, well, okay, I'll explain. So I did watch all of the Mindy Kaling's on Netflix. Never Have I Ever. Big reviews there. I really liked it. I thought it was super cute. Again, my anger with unrealistic high school expectations, but still, I thought it was super cute. I also watched Outer Banks. Like, talk about the most unrealistic high school experience ever. I looked at their ages and they're like high 20s. So, but it was a light-ish. I guess it wasn't super light now that I think about it, but it was okay. I feel like it's going to be a controversial statement that I say here, but it really wasn't my favorite. I would, not that I wouldn't watch it again. I would. Now, the reason I felt like I needed to explain was because I was catching up on Real Housewives of Beverly Hills and Real Housewives of New York. Oh, that's one of my cats. You guys are just seeing everything now. But Real Housewives of Beverly Hills just like restarted, and so did New York. And one of my friends was like, you've got to watch this season. So I did. And I had to like kind of catch up on them because I was a little behind. And let me tell you, wild. Those two are just, it's a lot, but talk about like a mindless watch. Those are good. So, now it's just come to like, I watch every single show on Bravo and I love it. So, I'm sure, I have actually been, I've slowly been starting Ozark. My friend told me I cannot put the S on the end because I always do. But I've been starting Ozark, and I've actually, I've been taking that one slow because it's heavy and it's a lot. So I've been watching like 1 episode a night. But that one's been good. And then I might have to find like another light one. But honestly, all of my Bravo watching has really kept me busy. So, but I hope you guys are doing well. There was my like TV recap for you guys. I know everyone's like, I don't care. You've probably stopped this video, but if you haven't, good on ya. Okay. I miss you guys. I hope you guys are doing well. Yeah, I miss you. I miss seeing your guys' faces. I miss getting up at 5 o'clock to be there. I do. So, I hope you guys are doing well. If you guys need anything, call, text, email, hang out, whatever you guys need, let me know. Bye guys. Have a good day.